All right, folks, so we are starting on the guided practice on the first page with number 10 down at the bottom. So starting with number 10, our top fraction is 10x over 5. Pew, pew. Our bottom fraction is those two getting added together. Now, taking a look at number 10, is there anything I can do to factor and simplify that top fraction?
No.
We can take a 5 out of the top and the bottom. That is a monomial, so take a 5 out, that leaves us with 2. 5 out, that leaves us with 1. So now on the top, I just have 2x. Woo! And this is all over. And you can write 2x over 1 if you want, but it's really just 2x. Now on the bottom, what am I going to need to find to add those fractions together? We need an LCD, and that LCD will be x times 3. So LCD, 3x. So I'm going to need to multiply the first fraction by 3 over 3 as a creative form of 1, and the other fraction by x over x. So that gives me, going straight across, 6 over 3x plus x squared over 3x. And now that we have a common denominator, we can add those tops together. But can I actually add 6 to x squared? No. Nope. So those are not like terms, so we're going to have to just leave it. So we have 6 plus x squared all over 3x. Now if you're like, well, that didn't do a whole lot, Miss Caro, it did change these two fractions on the bottom into one fraction. Even though we weren't able to really simplify it, it still is important for getting this whole problem down to one fraction. So now this is my top fraction. This is my bottom fraction. So if I want to take the top divided by the bottom, we keep the top, and you can put it over 1 to make it look more like a fraction if you like. And then we change the division to multiplication. And then we flip the bottom. So 3x over 6 plus x squared. Can I take the 3 out with the 6?
No.
The x out with the x squared?
No.
What about when I multiply straight across and I get 6x squared over 6 plus x squared? Folks, can I simplify that?
No.
It's very, very tempting, but this is a non-factorable binomial, so trap that sucker, and there is nothing that I can take out of the parenthesis or simplify with the 6x squared on the top. So our final answer is 6x squared over 6 plus x squared. Let's go ahead and move on to number 2. The second, actually number 8, sorry. We're going to move up to this one right above it. I want you to get as far as you can on this problem in 1 minute with trying to simplify the top by adding those fractions together. Yes?
I have room.
If you don't have room, has anyone else run out of room? I have scratch paper up here. I kind of planned for that. Anybody want scratch paper to work these problems on?
Just do it.
It's green. It's green.
All right. This is black.
So to add those two fractions on the top, we need to find a common denominator. We've got x minus 5, we've got x plus 5, so our LCD of the top will be x minus 5, x plus 5. So my first fraction will need to be multiplied by x plus 5 over x plus 5 as a creative form of 1. my other fraction will need to be multiplied by x minus 5 and x minus 5. Take it from here and see if you can simplify that top fraction. You'll need to distribute and then add the tops. So distributing to both, and then adding those tops together, we get 7x minus 5. On the top, over x plus 5, x minus 5 on the bottom. And I trapped that 7x minus 5 in parentheses because there's no GCF, so that thing is kind of its own factor. Raise your hand if you got that top part right. Okay, making good progress from yesterday. So now for the bottom, I only have one fraction, just 8 over x squared minus 25. So there's no real operation to carry out here, but there is something I can do to the bottom of that fraction. What do you think we should do? Factor it. So this is divided by 8 over x plus 5 and x minus 5. There's our difference of squares. So then top fraction divided by the bottom fraction, keep the top, change the sign, flip the bottom. So keeping the top, 7x minus 5 over x plus 5, x minus 5. Changing the division to multiplication and then flipping. X plus 5 minus 5 is now on the top. 8 is now on the bottom. So what can I simplify? The x plus 5s are gone. The x minus 5s are gone. Anything else? Nope. So 7x minus 5 all over 8 is our final answer. Folks, what questions do we have on this process? Why is it so long? I think then I'm going to turn you loose on number 9. Let's do that one. Give everyone a few minutes to work on this one. Before you get too far, what do you think we should do with that x squared minus 2x minus 8? Factor it. So that is x minus 4 and x plus 2. So use that factored form when you are finding the LCD of the top. let's regroup for a moment. So folks, your LCD of the top that we need in order to add these fractions together, the greatest amount of x minus 4s we have is x minus 4. The greatest amount of x plus 2s that we have in one fraction is x plus 2. So our LCD at the top is x minus 4 and x plus 2. The second fraction already has the LCD, so I only need to multiply this one by x plus 2 over x plus 2 to get to the LCD. On the bottom fraction, if I look at those two denominators, our LCD is the same as it is for the top. So we multiply by what they are missing. So x plus 2, we need x minus 4. X minus 4, we need the x plus 2. How do we do with that first step with finding the common denominators we need in the creative forms of 1? Now the super fun part of trying to simplify this. Now, this is why I wanted to regroup because, folks, when I go to multiply this first fraction by the creative form of 1, I have a binomial times a binomial. How do we multiply those? We FOIL. Very good. So, x times x, x squared. X times 2, 2x. 2 times x is 2x. And 2 times 2 is 4. So there's just the first part. And then I'm going to add that to 5. And just to save me a little bit of work, I'm going to put that over the LCD. So there's the top, more or less. Going to be less once we simplify that. And now let's look at the bottom. Now the bottom, no foiling necessary. That's just going to be some straight distribution. The 3 to the x, the 3 to the 2, the 8 to the x, the 8 to the negative 4, and adding those tops together over the LCD. See if you can complete that next step for adding those bottoms together. How'd we do? That's what the bottom will look like, but then of course we will be able to simplify both the top and the bottom by combining our like terms. So let's slide on over to our next line of work. For our top fraction, we'll have x squared. 2x and 2x is 4x, and then 4 plus 5 is 9. And this is all over x plus 2 and x minus 4. Can we factor the top of that fraction? We can try, but product of 9, sum of 4, we've got 1 and 9, negative 1 and negative 9, 3 and 3, negative 3 and negative 3. No can do there. So I'm going to go ahead and trap that in parentheses since that is not factorable. And we have divided by, combining like terms on the bottom, 3x plus 8x is 11x. 6 minus 32 is negative 26. And that is all over x plus 2, x minus 4. Can I factor 11x minus 26? GCF or otherwise? Nope. So we can trap that top in parentheses. See if you can carry out keep, change, flip. All right, folks, keep change flip. Keep the top. See me a little bit of room. I am just going to change this to be multiplying by the reciprocal of the bottom, right next to the top. So x plus 2. Thank you, x plus 2 and x minus 4. So now I am flipping the bottom. So the 11x minus 26 will be on the bottom. The only things that will cancel are the x plus 2 and the x plus 4, or sorry, x minus 4, so that our final answer, or what we are left with, is this non-factorable business on the top and that non-factorable business on the bottom. So x squared plus 4x plus 9 all over 11x minus 26. Trap, 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 trap. That's our final answer. Folks, what time are we out of here? 12:10. I think what I'm going to do is save this last complex fraction problem for tomorrow. And what I'd like you to do with the last 10 minutes of class that we have is finish up pages 3 and 4 in the homework packet, because those are due tonight. So if you haven't finished those already, go ahead and start working on them. If you are feeling confident with the complex fractions, because again, we only do have one more example problem to do, you can start working on tomorrow's homework, which will be pages 5 and 6. Use this time to work.